We've looked at the normal distribution, which is the most popular distribution. Now we will look at the sampling distribution, which is one of the most powerful. So the sampling distribution is the probability distribution of a sample statistic that is formed when samples of size n are repeatedly taken from a population. Every sample statistic has a sampling distribution. So the sampling distribution that we are going to be focusing on is the sampling distribution of sample means. So this is when the sample statistic of the sampling distribution is the sample mean. So the mean of sample means, which is represented by mu of x bar, is equal to the population mean, mu. The standard deviation of sample means, which is represented by sigma x bar, is equal to the population standard deviation, sigma, divided by the square root of the sample size, n. And sigma x bar is also known as the standard error of the mean. This diagram represents the sampling distribution of sample means. So the rectangle represents the entire population. Each circle represents a sample of size n. Now, because the sample entries can differ, the sample means can also differ. So the mean of sample 1 is x1 bar, the mean of sample 2 would be x2 bar, and so on. So the sampling distribution of sample means for samples of size n for this population consists of x1 bar, x2 bar, etc. And if samples are drawn with replacement, which means that a person could hypothetically be in more than one sample, then infinite number of samples can be drawn from the population. You have a population with the values 1, 3, 5, and 7. Find the population mean and the population standard deviation. So to find the mean, we just need to add up the 4 values and then divide by how many values there are, which is 4, and this is equal to 4. For the population standard deviation, I'm going to use the 1var stats. So I typed 1, 3, 5, and 7 into list 1 on my calculator and then computed the 1var stats. And we can confirm that the mean is 4. And the population standard deviation, rounded to 3 decimal places, is 2.236. You write the population values 1, 3, 5, and 7 on slips of paper and put them in a box. You randomly choose 2 slips of paper with replacement, so that means that after you select them, you put them back into the box. List all possible samples of size n is equal to 2. Also calculate the mean of each sample. So there are 4 samples or 4 combinations where 1 is the first number. There are 4 combinations where 3 is the first number, 4 where 5 is the first number, and the last 4 have 7 as the first number. So they also want us to calculate the sample mean of each sample. So looking at sample 1, we take 1 plus 1 and divide it by how many numbers there are, and because there's only 2 numbers in the sample, we're dividing it by 2, and this equals 1. For the second sample, we're taking the 2 values, 1 and 3, and dividing them by 2 to get 2. Next, 1 plus 5 divided by 2, which is 3. And then 1 plus 7 divided by 2, which is 4. And then we can repeat the process, and these are the rest of the sample means. find the mean of sample means and the standard deviation of sample means. So to find mu of x bar, we want to take the mean, or the average, of all of the sample means. So we're going to add all of them up and divide by how many numbers there are, which would be 16. And this gives us 4. And you'll notice that that's the same number that we calculated for the population mean. Next, we want to calculate sigma x bar. So I'm going to type all of my sample means into list 1 and then use the 1var stats to calculate this. So I typed all of my sample means into list 1 and then calculated the 1var stats. And the standard deviation is 1.581. Use the formulas to find the mean of sample means and the standard deviation of the sample means. So they want us to calculate the exact same thing, except for they want us to use the formulas. So mu x bar is equal to mu, and sigma x bar is equal to sigma over the square root of n. So I'm using the population mean, which is mu, and that's equal to 4, and the population standard deviation, which is sigma, and that's equal to 2.236. So mu is equal to 4. Sigma over the square root of n is equal to 2.236 over the square root of 2. So n is equal to 2 because each of our samples are size 2. And this is equal to 1.581. So we used the formulas and we still got the same thing.